Welcome to the Network Automation with Python session. My name is Christian Adell and I'm working as a network automation engineer at Network2Code, that is a consulting company offering network automation solutions at different scale. Today in this session we are gonna understand why is so important the role of Python as a coding language in all this transformation that is happening in the networking industry. Networking is everywhere. Today we are here all together connected over internet. Internet is just a network of networks that are running in different data centers, maybe public clouds, private clouds, campus networks. There are networks everywhere. And with all this increase of traffic, of connected devices, networks are growing. And two main challenges are arising. First one is scalability. So we have to handle more devices, a lot more devices than before, but also the reliability of these networks. Maybe it's not good enough to have someone behind a computer handling an incident. We will have to delegate this to a kind of a script or automation that handles with the logic that we can enforce, but in an automated way, because we cannot react so quickly. This field, the network management, has been evolving for the last 30 years that internet was created with the different networks until today. But the main changes started a few years ago. So even today, there are a lot of people that are still handling or managing their devices via a CLI or a graphical interface. This means that for every device, there is a specific language, a specific connection, and a specific data model. And as you can imagine, this makes that all the interaction is slow and sometimes it's not reliable, because just a typo can just break something that is running in production. In networking, something that is a bit challenging is that you don't have usually a dev environment to test things. Usually you work directly in production. How we try to solve in the industry? First step, and the one that we are ready today, is automating things. This is something that is not new for networking, has already happened to software development or systems, that using coding languages or automation tooling like Ansible or others, we can just leverage and make that some circumstances you can just take different decisions. And the automation is the point that we are gonna focus today. Next step, and is something that some big networks have already started this transition, is going to the young data model. This is, and you will understand it clearly, in this automation journey, we are working in a brown field. There are devices that everyone still has the CLI, people maybe already managing via CLI, so each one of these devices has his own data structure. But on the other side, young, and this is a collective effort in order to standardize what the configuration means globally. So the same interface configuration, the same IP configuration is the same for the different vendors. This data model organization and these standards are being developed under the ITF and the OpenConfig organization. So they are developing a generic structure of data, but not all the vendors are already at this stage. Not all the vendors, not all the devices, all the platforms. So for the time being, and this will take some time to go to this point that everything can be homogenized with this data model, we have to deal with some kind of automation that can handle legacy devices and also new devices. Within the network automation ecosystem, today there are a lot of different projects solving different needs. In some cases, we are solving how to organize all the data in a source of truth that we can consume later. In other cases, we are taking a lot of data to graph this data or to take decisions. But something that is common in any automation project that we are gonna have to work with in the future is that we have to connect to the devices. We have to enforce data, we have to consume data, and traditionally this has been done, as mentioned before, via CLI. If we want to put this interaction into a script, Python is offering us three main libraries. I'm gonna talk about this today, the three N's. First one is Netmiko. Netmiko offers a CLI experience via SDK. So you are working like if you were working on a CLI, but in an automated way. This has benefits because there is easy to implement in top of PyDayBCN the SSH connection to a device, and it has an easy support to a lot of vendors because you only have to make the same interaction that you have via SSH, but through an SDK. But on the other hand, you have to understand what is the specifically data model of this device, and the data that you are getting from the device is raw data, is text. So you don't have a dictionary, you have a text that you have to parse, and there is other libraries, projects that are offering this solution, but yeah, you have to get this data and process to get something that you can consume. The next evolution of this project, that is a different one, that is Napalm, is solving some of these problems. So is leveraging in Netmiko in some cases for the devices that only support Netmiko. In other cases is supporting APIs, REST APIs, or even netconf or other networking protocols that are offering young capabilities. But in this case, the important point is that we are using a command-oriented, so we don't have to deal with the specifics of a vendor, of a platform. You are just, okay, I want your BGP neighbors, so give me them. Not I have to remember what is the specific CLI command. Obviously, this has a big benefit. And the other one is that the information that you are getting is not a text, is a actually parsed data, like a dictionary, and is the same for all the vendors. So this is nice because you can get the same data from different vendors, understand what they mean, and take decisions. And finally, Nornir is not the library itself, is actually an automation framework that is leveraging on the other ones, in Netmiko, Napalm as drivers and more, and gives the operator the experience that I don't have to care too much about coding. In this case, it's more about defining what is the state of the network that I want. The good point here is that you have all the power of Python debugging utilities just to use Nornir and just automate your network. And now, before going into the demo, I want to give you a good reason to stay here and end this presentation, because maybe you as a Python developer doing backend, frontend, you have been wondering, yeah, this looks interesting. I see that there is a lot of community working on these projects, but this is something that I can have to deal with at some point as a Python developer. And my answer is going to be maybe. Network automation is not only for network engineers. In my case, I'm coming from a network engineering background, but working as a network automation engineer like me, there are people that is coming from the other side. So there are a lot of opportunities that are coming up that maybe will be interesting for you as a Python developer. So now that you are motivated to go into the demo today is gonna be focused in Netmiko and Napalm. We don't have time for everything. So the scenario that we are gonna work with is this simple scenario that you can reproduce in your laptop using the link that you have here in my public GitHub. It's using two public open source routers, BIOS, that are connected together via a link that is not configured. We are gonna configure in the demo. And then just from a management server, we are gonna connect to these two devices. So let's jump into the demo. So let's start this demo where I'm gonna show you what are the main differences between using Netmiko and Napalm as libraries to connect to the network devices. Let's go into the interactive session and we are gonna start importing Netmiko. Here we can just check what Netmiko can offer to us. Netmiko, as you are gonna see here, there are a lot of vendors: Cisco, Citrix, Broadcom, Aruba, a lot of them, because at the end it's pretty simple to integrate Netmiko with a vendor. You only have to support the basic SSH connection and then handle the different modes that the specific vendor or platform supports. If we want to check for a specific vendor what is supported, we can check Netmiko and give me what Cisco platforms are supported. I can see here Cisco XR and XOS, different flavors, because maybe there are different specificities on the connection of each device. Now let's start working with the device, and first we have to establish a connection. So let's go into Netmiko connect handler. That is the method that we are gonna use to connect and establish the connection. So the host that we are gonna connect, remember that we have two routers. In this case, we are gonna connect to the router A. It's important to define which device type we have, because this will mean which is the driver that we are loading behind the scenes. The username, you can understand that for a demo is just background, and the password is also background. Here we are. This takes a bit, and this is because we are actually connecting to the device. When this is done, we can check what we have in the connection. And there are a lot of different commands. But all these commands, if you have a bit of attention here, you can see that, yeah, these are the kind of commands that you need to interact with the device in a CLI, if you have already interacted with the router. So go into config mode, go out of config mode. There are not generic or abstract methods. Let's start with the first one. That is one that we are going to demonstrate how it works. So we have the connection. We are going to assign this to a variable to get it more pretty, the output of this. And we are going to send a command. Notice that we are sending a command that is a specific command for this device. I already know about this command that is giving me the information about the interfaces. So what do we have in the result? In the result, we have the information on this device. As I mentioned, we have Ethernet 1, that is the management interface, and Ethernet 2 is not configured. Notice too that res is a string. It's not a dictionary that could be easily to parse. In this case, is a string that if we want to take this information, we have to start using text scraping that could be a bit difficult to achieve, and also will differ a lot from one platform, even the same platform in different releases. So now let's move a bit up on the connection challenge, and let's go into the config mode. Config mode is the mode that we are going to use in order to actually submit some commands. And when this goes into this mode, I'm going to send a command, my connection. Notice that the method is the same, so send command. I have to know about the syntax of this device, and I'm going to configure the interface. So the interface, that is type Ethernet 2, I'm going to give it the IP 02100/24. So I'm giving this command, I'm sending to the device. Because the way that this device BIOS router works, the command that I have submitted is not actually applied. I could check the diff on this command, just getting what is in the config mode right now. So I can just say, okay, give me connection, send command, and I'm gonna ask for the show interfaces. Notice that I am giving the same command that I gave before to get the interfaces, show interfaces, but in this case, I'm in the config mode. So because I'm in config mode, what I'm gonna get here is a different output. And the output that I'm getting, you can see, is the configuration that is actually in the devices. And the important part here is that I'm with this plus, we are adding this new address on this interface. Finally, if I want to commit this configuration because I'm happy with it, it's as simple as saying, okay, my connection dot commit. So I am just actually committing this configuration. Now, if I want to check from the operational mode if this is configured, I can exit from the config mode and submit the command again. Now it's going out from the configuration mode to the operational mode. This is particularly to this vendor, this platform. This warning is not important because it's just saying that the configuration is not going to be saved for later. It's just running operations. And let's check what I have in, if you remember the command, because actually it's the same. It's make connection, send command, show interfaces. Now what I'm expecting to see here is that the interface that I have configured is going to be here. So I see that the IP that I configured is live. This gives us the flavor that, yeah, it's possible to interact in a programmatically way with this router, but yeah, I have to know about, there is an operational mode, a config mode. I have to understand or to remember what is the specific command, and this is obviously could be a bit overwhelming when you have to deal with a lot of different vendors. So now it's time for Napalm. First thing, same, just import the library. And in Napalm, there are two steps. We don't get the connection directly. First, we get a driver. So from Napalm, we get network driver. And I am defining which kind of driver I want. In this case is BIOS. And then I can create the connection. I'm reusing the same variable name. Obviously, I don't have to specify which driver I want because I have already done. So I only have to define which is the hostname. In this case, I'm going to target the router B just to complete the scenario. Router B, username is the same, and password obviously is the same. Good. So the connection is there. In Napalm, there is already an extra step. That is that the connection, to be effective, has to be open. And this is the one that takes a bit because it's actually connecting to the device. Let's do a quick check on what are the methods that Napalm is offering to us, because this is going to give us the first understanding of the difference between Netmiko and Napalm. So for instance, this one, get BCP neighbor detail. You can see that this is an abstract command. It's not defining how I have to deal with BIOS, how I have to deal with Cisco or Juniper. It's a generic command. And then Napalm, what it does behind is translates to the different commands that he's already aware. And it's important because it's gonna give us the data in a structured data. So it will be more useful for us to understand, but better to show you than describe. So let's get the same information that I got before. So from my connection, now I want to get the interfaces IP, and this is generic. First thing that I want to show you is that the rest is not a string now, is a dictionary. So if I want to print the rest, is actually a dictionary with keys. So I can access a key, and I can just filter the data and manipulate it in a more effective way. Let's try now to go into set up a change. If you remember, we have changed the IP of the Ethernet 2 that is connected to this router. So let's do here the same. Here there is a generic method that is merge candidate configuration. And the config that we are gonna set is byte set interface, is the same command, because at the end, for configuration commands, we have to handle or deal with the actual syntax of the device. And we configure the other IP, that is this one. Remember that for router A we used 100 and this is 101. The connection is giving this configuration into the device. Next step that we can check is if there is actually a change. Maybe we have set a configuration that is not having any effect because it's already applied. We are comparing the configuration and see, okay, there is a new command that is coming in, that is this IP. Good. I am happy with this. Hopefully, yes. So let's commit the config. And you can see that the way that we are dealing is a bit different. Yeah, for sure we have to still push some configuration manually, but the way that we deal, it's a bit more advanced and will give us a lot of benefits. Then, when this configuration is pushed, I can just do a ping. There is a command that is actually abstract, that is ping, and I'm gonna ping the other router. That if I have configured here 100, the other router is 100. Sorry, 101 here, 100 is the other router. So let's do a ping. This is gonna take 5 seconds because by default this ping has five profs, but now I can just print this and maybe just to give it a better output, just do like this. Dumps of this result and with an indent for it will be good. So this is the output of the ping. The important and the most important difference between Netmiko and Napalm is that this print, this output, this result, if you see is a dictionary, and this data structure is the same for BIOS that would be for another vendor. So I can always look for this key, success, and then for the specific results of this IP, the round trip time, and the packet loss, and all the data that I can then leverage to take the decision that I need, independently if it's a specific vendor or it's another. So it's easily to handle and to deal with all this data. And this brings us to the end of this presentation, where we have explored the main difference between using Netmiko and Napalm to connect to the devices and automate the network. But the most important point for me that you should be taken from this is the key role that the Python community is having in this transformation. So I encourage you just to take a step here and check what the community is doing, and if you have any important role that you can develop in this transformation. So thank you very much for your attention, and if you have any question, just use this time or contact me later in the social networks. Thanks.